Math 8. So, more scientific notation stuff. Hopefully the writing in scientific notation hasn't been too bad. That's what you'll be finishing up. But after that, we're going to get to adding and subtracting in scientific notation. Okay? It's not as bad as you think, but you do need to understand what scientific notation is to make it a little bit easier. We have 2 examples. It's going to be real short. So let's get started. So, example 1. We have 7.6 times 10 to the 11 plus 2 times 10 to the 11. Okay, now, the reason you need to write this in scientific notation is it becomes a lot easier. Instead of adding something that's like 760 billion to 2 billion and stuff like that, writing all that down just seems exhausting, okay? One thing you'll notice is that in order to do this successfully, our exponent on our base of 10, okay, so 10 to the 11, 10 to the 11, they need to be exactly the same. If they're not the same, the math isn't going to work out, okay? If I had something like 3 times 10 to the 4th and 3 times 10 to the 3rd, okay, well, these two things give you 2 different things. If I were to add those, it wouldn't work out. We have 30,000 and 3,000. Okay, so they're actually different numbers. Here, you're going to have the same amount of decimal places for both of these. So it's going to be something easy to add. You know, it could be like 7 billion, 2 billion, you know, whatever it may be. Okay, so they have to be the same. You notice here, they give you different numbers, so it's not actually going to work out. So all we do is we do the math with whatever numbers we have. Okay, you can see example 2, we have different numbers over here. Whatever numbers we have, we do that math that it shows us. So 7.6 plus 2. Write it down. Okay, there's not much work here. 7.6 plus 2. Now, a mistake people will make is they don't know where to put the 2. Technically, this 2 is 2.0, so it's going to go here. Okay? It will help if you put the point 0 in. And then you add it up. We have a 6 here. We have a 9 there. So we get 9.6. I'm going to write that down. And then we're going to keep that same exponent that we had. So 9.6 times 10 to the 11. And that is my answer. Okay? If this was 760 billion plus 200 billion, you'd have 960 billion. Okay? If it was 4,000 plus 3,000, you'd have 7,000. It's going to stay that same. Okay, so it's just like it's staying the same in the thousands, it's going to stay the same for your exponent. Okay, pause the video, write it down if you need to, and then go ahead and try example 2 on your own, and we'll go after it. So, similar problem here. Instead of addition, we have subtraction. It doesn't actually change the steps. Okay, you got to do the math. So we have 8 minus 2.2. Okay. A little bit tricky, but it's really not that bad. You still got to just, write it down. Technically it's 8.0. We're going to borrow 1. Make that a 7. Change that to a 10. 10 minus 2 gives you 8. Bring the decimal straight down. 7 minus 2 is 5. So I have 5.8 times 10. And again, we keep the exponent. Even if that exponent was a negative, we'd still be a negative exponent. So I have a 4. And that is my answer. That's all we do for here. The main part is 1, remembering that they need to be the same. And 2, making sure we don't mess up the math with the decimals. Okay? That's it for this lesson. The next one is going to be multiplying and dividing, which again isn't too bad. Separate set of rules though. But for now, that's it, and I'll see you next time.